Dear students, welcome to the session of Harmonics. Harmonics topic is under power quality. Unit 4 and Unit 5 are assigned for the topic on harmonics. Today we'll have a discussion about harmonics. Before that, let us understand harmonics with a simple experiment. Connect CRO to your place where you are sitting and remove the computer from the supply or switch off computer. Now if you observe voltage and current waveforms on cathode ray oscilloscope, then you will observe that they are purely sinusoidal. Now in the second step, switch on computer and printer or any other electronic devices. You will observe that there is a flicker in the voltage, there is some sort of distortion in the voltage. At the same time, current waveform is also distorted. So this is because of harmonics. The presence of harmonics distorts electrical signals. Therefore, power quality is affected because of presence of harmonics. And therefore, harmonics has been considered as an important topic in PQ. Now, harmonics can be broadly thought of as non-electrical and electrical harmonics. As you can see here, these are non-electrical harmonics. The harmonic generated by piano, woodwind, or SHM, that is simple harmonic motion, are the examples of non-linear harmonics, non-linear or non-electrical rather, non-electrical harmonics. In your 11th standard, you have performed the experiment of tuning fork, in which you have you have created vibrations of that tuning fork. So these are harmonics. In total, the frequencies will add up to give total harmonic note. Same is the case with piano or trumpet. So they are also creating harmonics. They are amazing us by creating harmonics. But that is not the case with electrical harmonics. Electrical harmonics are not at all amusing. They are not at all making us comfortable, but they are causing headache because of number of problems. So under this subject, we are going to study the electrical harmonics. In electrical harmonics, we can define harmonics as an integer multiple of fundamental frequency. So harmonic waves are sinusoidal waves which are integer multiple of fundamental frequency. The fundamental frequency is 50 Hz in India. It is 60 Hz in other countries like US. So therefore, n into fundamental will give rise to harmonics. Like 1 into n, 1 into f rather, is fundamental and so on. We'll see it later in coming slides. So in this way we can define harmonics as an integer multiple of harmonic frequency. So any complex waveform is a sum of even and odd harmonics of lesser and greater value. So in this way, number of harmonics are added together to give rise to a wave which is in this complex wave. Now as you know that we are having sinusoidal input to number of devices. If you are giving this type of distorted wave, then it will have erroneous operation. It will maloperate. The equipments to which we are applying such wave will be maloperating because modern electronic devices and circuits are designed for pure sine wave. In the absence of pure sine wave, it will cause misbehavior like undue tripping of transformers or breakers and number of such things. So in this way, harmonics are playing important role in power quality considerations, and we should have clear cut understanding of what are these harmonics. So these are the types of harmonics like fundamental, second, third, fourth. So fundamental is 1 into 50, that is the 50 Hz frequency. Second is 2 into 100, 2 into 50, it's 100. Third is 3 into 50, 150. And fourth is 4 into 50, 200. So in this way, different frequency components will be produced and they will be added together to give the resultant which is non-sinusoidal and which is very harmful to the electrical systems. As you can see here, three functions sin x, sin 2x and sin 3x are added together. The first graph gives a sine curve, second graph gives a sin 2x and the third graph gives sin 3x. So in this way, number of graphs are added together to give rise to a complex wave. Now, Fourier series is an ideal tool for measurement of these different harmonics. As you can see here, number of harmonics are added up together to have a composite wave. Now, second, fourth, these are the even harmonics, and even harmonics are symmetrical and equal and opposite in number of cases. Few exceptions are there, but mostly the even harmonics are equal and opposite of magnitude and therefore they will cancel each other. Therefore, in most of the systems, the even harmonics are absent and the odd harmonics are predominant harmonics. They will have more share in harmonics. So that is predominance of odd harmonic or odd order harmonics. So it is important to note that vast majority of harmonic currents found in distribution systems are odd order harmonics like third, fifth, seventh, etc. So it depends on type of device where these harmonic components are coming in, and therefore, depending on that type, for example, personal computer will have third, fifth, seventh. Steel mill may have some different rolling mill or steel mill. They are having different harmonic predominance like 7th, 9th, 11th, etc. Now coming to historical background, harmonics were first invented in 1923 by German engineers. They were studying different types of waves on CRO and suddenly they found that there is some disorder in the sinusoidal wave and they named this as a harmonic wave because it is sum of different types of harmonics. Harmonics are generated when electricity is controlled by electronics. So the reason behind formation of distorted wave or having different components is attributed to electronics. Modern electronics devices and circuits are the main culprits in generation of high order harmonics. When we got freedom in 1947, at that time the connected load was only 1750 megawatt. At that time the load was a linear load, preferably. Therefore, problem of harmonics was not there. The loads at residence was fan and light, like that, which was totally linear, and therefore for a very long period, up to 1990, there was no such nonlinear loads to the extent to create harmonics, and therefore the problem of harmonics could not be realized at that time. However, after 1990 or in early 90s, there was a arrival of LPG policy, that is liberalization, privatization and globalization. Because of formulation of this policy, the free trade was promoted, and lot of industries, including IT industries or steel industries, were set up. So this led to very good progress. But over a long term, it was felt that they are giving exponential rise to the nonlinear load and therefore inviting harmonic distortion. So that was the main issue during that period. And although nonlinear loads are helping us in improving our economy or improving horizons of progress, but still the problem of harmonics is arised because of nonlinear loads. So nonlinear loads are they draw the current in a non-sinusoidal manner. That is their property. That they will form the current which is not at all sinusoidal, and they will add up that current with other components of current, and it will distort the system. Not only that, the currents which are generated by nonlinear load tend to flow in the system, and if they come across some bus nearby, so they will flow through current through the bus and form harmonic voltage across the bus. So in this way, harmonic currents are generated by nonlinear load, and these currents give rise to what is called as harmonic voltage. So the problem of harmonic current and voltage is therefore to be studied and analyzed. Now harmonic distortion is also one of the topic of discussions. Basically, harmonic distortion is nothing but harmonic disorder or harmonic pollution that is developed by nonlinear loads. So the harmonic distortion of current occurs when the sinusoidal voltage is applied to a nonlinear load. For example, electronic ballast, PLC, adjustable speed drives, etc. are the examples, or any DC AC converter. These are also examples. So in this way, these are the certain examples of nonlinear loads. In next video, we'll see details about nonlinear load and further part of harmonics.